Okay. So our topic today is Docker. Okay. So no one have no idea, right? I mean, what is Docker? This is actually a tool. Heard about Docker before? Pooja, Dipti, I'm audible, right?
Yes.
It is used to containerizations.
Right. So it's a containerization tool to run our application within containers. Okay. So coming to the latest trends, all applications are microservice applications. Okay, like for example, if we take a 3 tier or 2 tier applications, a front end and back end or any other service. So we decoupled that monolith application to microservice application. Okay, so each services, like for example, the front end or the back end will run in each container.
काम करते खाना मेरे को ला के देते Sorry, I'm not in mute.
So coming to the theory part of Docker, and Docker is actually a open source uh, open source platform that we use for automate the deployment. Then we can deployment, scaling, and management of application. Okay. So coming to Docker, inside Docker, it's a lightweight portable container actually. Okay. That's container is a lightweight and it's portable. So when we use these types of Docker tools or Docker container, it's it simplifies the process of building, testing, and running application with that application packaging, and it's like packaging them along with their dependency actually. So for example, if we need to run an application, okay, so for running an application, that application needs some prerequisite like the application dependencies, libraries, framework. So all things wrap up within a container, and that container will run the application. So we didn't bother about any other services or any other framework or dependencies. Only we bother about the corresponding applications, dependencies, packages, and framework. That all things that we need to bother. Okay. So some key concepts of Docker, like it's a lightweight and standalone executable package. So that include everything needed to run a piece of software. Okay, or a such code or libraries and dependencies. So each containers within the environment are isolated from each other. For example, we installed the Docker engine, and inside the Docker engine, we deploy so many application using containers. Okay. So each containers are isolated from each other. Then it's provide a consistent environment regardless of where they run actually. That's why we isolated each containers. Okay. So there is no connection by default with the different container in a same infrastructure. First one is container. Image. The next thing is image. And the third one is Docker file. Fourth one is Docker hub. Docker hub, Docker engine. So these are the key concepts of Docker. Okay. So we need to go through each concept. So coming to image. Okay. Coming to image. It's a read-only template that we use to create container. Okay. It's a template, read-only template that we use to create containers. Docker images are built from a set of instructions, okay, like using a Docker file and can be reused or shared via a registry, okay. Then coming to Docker file, the third one, Docker file. Docker file is actually a text file that containing like that's containing a series of commands, okay, or instruction that we called commands or instruction when coming to Docker file. It's a text file and it's containing a series of commands and instructions. So we need to learn the commands and instruction that we given within a Docker file. So these commands are...
Sir,
Yeah.
is that a Docker Compose?
No. This is a Docker file actually.
Okay.
Docker file, Docker Compose we used for deploying multi-container within a single file. Okay, we're using a YAML file that we will learn in coming section. So yeah, that text file contains a series of commands and instructions used to build a Docker image. Got it. So Docker file is a base thing to create Docker images. Okay. So the Docker file includes steps such as installing dependencies, copying code, and running application. So everything is, we provide everything within the Docker file actually. So the Docker file, when we running the Docker file, what are things that we include in the steps like installing dependencies or copying code and running the application. So the next thing is Docker Hub. Docker Hub it's a public registry, okay, where we like the Docker image can be stored and shared, okay. It allows users to pull images from or push images to the central registry. It's similar kind of a GitHub, like it's a central repository where we pull our images and whenever we need we can...
Sir, can you repeat again from a public registry and it allows?
Yeah, it's a public registry where we use or where we pull the images, okay, or push the images
Okay.
for storing and shared. So the Docker Hub allows us to pull image whenever we need or push image to the central registry. It's a registry actually, okay, where we keeping our images, Docker images. Got it? Or confused? Like it's a registry, cloud-based registry, okay, Docker Hub. So how this is our local machine. Okay, our laptop. So here our image is ready. Okay, image is ready. We build the image using Docker image. Using Docker, Docker file, we created an image. After that, that image belongs to this local machine. Okay, so we need to save the image. Okay, so how we will save? We have a Docker Hub account. Okay, here we created a username and password, and we can see our Docker Hub account in our this is a web application. Okay, Docker Hub is a web application, so we can see whenever we log into the Docker Hub, and we use our username and password to log in. After that, we can push the image to this Docker Hub. Got it. So leave the laptop. Okay, we after some time. Okay, after 1 month, we log into another laptop. Okay, so we need the same image. So what we will do? Nothing. We just log into the Docker Hub and we can pull back the image to this laptop. This is a laptop 2. Okay, and this is a laptop 1. So similar way we can use the Docker image. I mean, we can pull the image from any environment, any PC, anywhere. Okay, that's why we use Docker images and pull the image to Docker Hub. This is a central repository. Repository to save images. Here we can see a lot of images like public images and private images. Public and private. Public images, we can, some open source images are there, like common images for running some application. We can directly pull from Docker Hub. Got it. Going forward, we will pulling image from Docker Hub. So that's the Docker Hub. Then Docker Engine. Okay, that's a one of the key concept. Docker Engine, it's a core software that enable Docker to run containers. It includes daemon, REST API, and a command line interface. So first we install this Docker engine. Okay. After that we will create the containers. I mean that there is a daemon behind the user and the Docker engine actually. So the daemon will communicate with the user. User means we are the user. Okay. So we need to talk with our Docker engine via Docker daemon. So coming to some common features of Docker, like it's we use the features are there. Okay, the Docker features. The first one is portability, then isolation, efficiency, version control, automation, security, network, and resource efficiency. So I will J. So why we call the portability? Coming to the first feature. So the Docker container can run on any machine that support Docker. That's why I told you previously, we have 2 machines and we can pull the image and push the image and run the Docker image. Only the prerequisites are it support the Docker. And it's ensuring a consistent environment across different systems like deployment, testing, and production. So the next one is isolation. So I told you each containers, okay, each containers within the same Docker engine is isolated from the host system and other containers. So that will ensuring that an application environment remains consistent and unaffected by other containers or other users or groups. So coming to the third feature, the efficiency of container. Okay, containers share a host operating system's kernel, making them more lightweight than virtual machines, which require a full OS for each instances. Efficiency. So I will give a brief idea how we will, I mean, what are the things that we used before the Docker? Okay. So you will get more clarity. So we have a requirement, okay? We have a requirement. Leave the Docker and everything, okay? We have a requirement. That requirement is to deploy a web application. Okay, a web application. So, yeah, this is a requirement. So, how you will approach this deployment? I mean, this scenario. Anyone can say. For example, to fulfill this deployment, we need to, some steps are there. Like first, we need a infrastructure. Second, we need to install the dependency for running the web application. Like we need to install any web server. Then we need that code, right? Application code. These are the common requirements that we need to follow to deploy a web application, right? So coming to infra, which infra we can choose? Anyone? The infra in the sense of where we deploying and setting everything.
Linux server.
Linux server, right?
Yeah.
Next. Only Linux server?
We need a DNS server for routing IP.
Yeah. I mean, I'm talking about the infra actually.
Okay.
Yeah.
All the package libraries that the web application requires, we need to install those package libraries. That includes HTTP.
All the package and the dependency we can install within the same Linux server. I mean,
Right.
the infra, different types of infras are there, right? Right.
So networking resources would not come here.
No, I'm just talking about the infrastructure.
Okay.
Infra in the sense of like computing. Okay.
So the DBs and all those can come.
Yeah, that we can configure within the Linux server, no
Oh,
problem.
okay, okay, okay.
We can spin one more Linux and configure the DB, and we can connect with those machines. So keep in mind when we're deploying any application, okay, when we're deploying any application, I will briefly explain in traditional way, okay. So in traditionally, like before 2030, 2030 or 12, okay, how we were deploying application, I will tell you. In that period, the same scenario, how to fulfill this scenario, okay, web application deployment. So what we will do, we need to buy servers. At that time, there is no cloud, there is no AWS or Azure, okay. We need to go to shop, then buy one server. Yeah. So what we will do, we buy servers. So So this is the server, okay. So server looks like a blade, okay. Different shapes are there for server. So most servers look like a blade model. So it's less space we can hold a lot of server, okay. So we buy a bare metal server. We called this server as a bare metal because the only hardware there, okay, no software there. So we need to install the software. So first we need to buy a server. This server costs like 70,000, 80,000, 90,000. It's starting range that is a starting range. So go to above, it's going to 1 lakh, 2 lakh, 3 lakh. It goes, okay, as per the requirement. So first we need to buy a server. So after that, on uh, on top of the server, okay. So normally we buy laptops and desktop. I mean personal for us. Like so we buy the personal laptop or desktop. Then on top of the that machine we install operating system like Windows 7, Windows 8, like that. Okay. That case for the personal laptop or personal desktop. So coming to the server, on top of this bare metal, okay, after buying the server, on top of this we need to install one software called um, on top of the server, we install one software, okay. That common software is called VMware. This is a bare metal server. So we buy the bare metal server, and top of the bare metal server we install VMware. So what is VMware? VMware is a software to virtualize the bare metal server. So why we need to virtualize?
So that we can divide the server between divide the bare metal and install multiple Linux servers.
Hmm,
Rather than having one big server, we can have multiple smaller servers that can act as a load balancer or a DNS or a database server.
right, right. So, so coming to the bare metal, I will explain the bare metal configuration. Okay, this bare metal have 16 core CPU power. Okay, that means processor. Then coming to that machine memory. Memory comes under 128 GB. 128 GB. Okay, this is just a rough figure. Okay, 128 GB RAM. And coming to storage. Two TB hard disk. Okay, so this is a configuration of this bare metal. Okay, so after buying the bare metal, we need to virtualize this bare metal. Virtualization. For virtualization, we need to choose corresponding software. Okay, one of the common software is called VMware. So on top of the virtual machine, we need to install the VMware. Okay, and after installing VMware, we will get some GUI, I mean graphical user interface console. So we need to go there, and from there we need to create we need to install the required operating system. For example, for this machine, we can install Windows operating system. So we install first VM. So here, after virtualization tool, we called these machines, okay, that we install in the bare metal, we called as virtual machines. Virtual machines. So the first virtual machine is Windows. These are the things as per the requirement, okay. For example, the requirement is you need to install 2 Windows and 2 Linux, then we can go follow the requirement. So we install Windows machine there. Then the another requirement is we need to install Linux. So we install Ubuntu or any other flavors of like Red Hat. Again, we install one more Ubuntu, okay. Ubuntu. So here we can call these machines, these 4 machines virtual machines, VM. And at the time of installing these machines, okay, the Windows, Ubuntu, Red Hat, this Ubuntu, we need to allocate the resources. The resources of we have 16 core CPU for the bare metal server and memory 128 GB and storage 2 TB. So when we installing and configuring the first Windows machine, we need to allocate the resource. Okay, for example, from the bare metal. Okay, so bare metal 16 GB, 16 core CPU there. So first we need to divide that core and allocate it to the Windows machine. That is, we need to allocate 4 core for running the Windows machine. 4 core, that is CPU. Same way we need to allocate the RAM. We allocate 16 GB RAM to the first machine. Okay, these are all the things as per the requirement. Okay, so coming to the next mission, say we do the same thing. Like we need to allocate the memory and storage and CPU core. CPU. We need to divide with this bare metal configuration. Okay, so we can divide like 4 for this, 8 for this, so 12, then only 4 there left, right? So we can do 2 for the last 2 machines. So similar way we can allocate that resources as per the applications. Okay, for example, we need to run some application within these servers. Okay, so as per the application purpose, we need to allocate the resources like core and CPU and memory storage, everything. And after these machine configuration, we can go with the application deployment. For example, this is Windows machine. So we need to run some Windows-based application like .NET application or anything. So we can deploy application, .NET application. So this is our application. Same way, on top of Ubuntu server, you can run application. So this is a way how we running application traditional way. This is before Docker, okay? Application. Got it. Anyone have any doubt?
No doubt.
No.
Okay. So, coming to this scenario, there is a lot of like demerits are there, okay, in this setup. Like, can anyone specify the, the demerits or the disadvantages of this types of deployment? Anyone?
Your app is not running in a uniform environment. So any bugs that will be on Red Hat may not be on Ubuntu, may be on Windows, but may not be on Ubuntu. So if it's inside a container, then it doesn't matter what the operating system it's on. It can pretend that it has its own environment, and you can test it and you repeat that environment. So somebody might have Python version 3, somebody might have 2.9. Then you won't be able to test and run everything uniformly. You will have to set up each environment separately, right? Each software and interdependencies you have to install. Whereas if it's in a container, you just move the whole container, copy the container. So it's like an image on your computer. It's like what the container is. It has the whole thing. Just like in the old days, people used to buy a PC, install everything on it, and run it, use it. The same way, it's just all installed on the Docker container, and then just move the whole container, copy the container.
Yes, but some other common things are there, like when going to these types of infra setup or scenario. Did you notice that?
You need the VMware.
VMware we use for the virtualization, right? Virtualizing our bare metal resources and allocate to the required operating systems. So one thing here we need to notice that resource utilization. So I will tell you, okay. So for example, coming to the any application, okay. See here on top of this operating system, we're running application, right? So for running a application, this is application. I'm taking this example, okay. So running a application, okay, in below you can see we are running a entire operating system, Ubuntu. Here as well same, running a entire application. Operating system that. So coming here, for running a .NET application, we need to run a entire operating system, that is Windows. So this entire operating, for example, when we need to run, okay, for example, any application, the .NET or the Ubuntu application or a .NET application, for running this application, that application only need that application dependencies, libraries, and framework that related to the specific application. So no need to run any entire operating system for running the specific application. So if we run this entire application, that means lot of resources we use, right? For example, for taking a class, I need only this paint, then then what, like AWS account, then That's a requirement, right? So for that, in this this is my local machine case, okay, in my case. So for that, I run lot of Windows related service in background, right? So that service is utilizing my memory, CPU, and everything. You got the point, all of you. So running this .NET application, okay. So running this .NET application, that .NET application needs the libraries and that dependent things only. For that, for the same scenario, we run an entire operating system like Windows. So the Windows have a lot of services that running in background. So that will utilize our resources, these resources. So we need to pay for that as well. For example, here we allocate 4 GB RAM, okay? Oh, sorry, 16 GB RAM and 4 core CPU for Windows. So running this specific application only need like one core or anything, one core or the application requirement, okay? Like one core or two core. Then the memory is same. We allocated like 16 GB memory. For running this application only need 1 GB or like that. For that, we need to allocate this entire infra to the specific Windows machine. Similar way to the Ubuntu and Red Hat and that and other OS as well, okay? So here we can't utilize our resources correctly. Mm,
Is it like duplicate use of resources, duplicate, triplicate? Every machine is going to take
No,
all
no.
those resources. But
No.
Docker would have been like just a container that asks for what it needs.
Yeah, this is the traditional way, okay? Now we are going to the same scenario we deploy in Docker. Then you will get more idea how we will saving our resources coming to the Docker environment. Can't use resources correctly due to due to the correctly we can't using the resources. The main problem is cost. Good. The next thing is we running application. Here you can see that each application running using a operating system, Windows, Linux, like that. Okay. So for example, if any issues happening within the operating system, our application is down, right? Well, the bare metal is running fine. VMware also fine. Coming to application have some issues or some problem, our application is down. So that's another scenario. So we need to go to the Windows machine, enter Windows machine, and we need to troubleshoot the issue and run it back. Okay. So that's another issues that we face. So these are the main things. Main thing is resource utilization. Okay. We can utilize properly when coming to this scenario. So when coming to Docker, okay. Anyone have any doubt? So coming to Docker, we need the bare metal, right? So we need to buy a bare metal server. Okay. So, and on top of the bare metal, this is Docker scenario. Okay. This is a traditional scenario. And Docker scenario, we need to buy a bare metal same way. This we need to buy a bare metal, and on top of the bare metal, we will install a operating system, not install any virtualization tool. Okay. We can install any operating system. So this is a bare metal. Bare metal. So bare metal we called as like this may be a VM, okay. In coming to the cloud environment, we can call as virtual machine, VM or physical machine. Virtual machine in the sense of cloud, okay, because coming to cloud, we called as that machine as virtual machines, not like this virtual machine, okay. or physical machine. We can do the same thing in our home lab as well or in physical environment as well. So we have a physical or virtual machine, and on top of the virtual machine, we install not these types of virtualization tool. We install any operating system like Ubuntu or Red Hat or Windows. As per the requirement, we need to install any operating system. So in this case, we have a machine, and on top of the machine, we install a operating system. And on top of this operating system, we need to install Docker. We called as Docker engine. Okay. So three things: the bare metal. On top of bare metal, we install any operating system. On top of Docker engine. And on top of the Docker engine, we can run applications. App 1, App 2, App 3, like that. App 4. This is called what? Anyone? Docker container. So here container 1, container 2, container 3, container 4, container 5. So coming to the scenario, okay, I will explain one more thing, the resource utilization. So same way these machines, this bare metal machine have like 16 CPU and like 32 GB RAM. Okay, just take an example. Okay, so we need to specify the resources, and this is our resources for the machine, and we allocated on top of the virtual machine, we allocated everything. Okay, so here we can allocate these resources to that specific containers for running. Containers means a lightweight, small environment. Okay, like it's a small environment to run our application. So here only for this application one needs, this is like a Python related application. Okay, this consider this is a Python application. This is some other application like Laravel or Java. This is Spring Boot. This is .NET. Similar kind of applications are there. Okay. So running this application, only we need to bother about that application dependencies framework, everything. So all the things within the container. So the container runs itself. Okay. We didn't bother about anything. We need to add all the dependencies, libraries, framework within the container, and we can wrap up. Then after we can run the application. So each container here is isolated. There's no connection in between. Okay. Like we can create Docker network for networking, but by default, there is no connection between each containers. All containers are isolated. So here, in previous scenario, we run the entire operating system for running application. Here we didn't install, we didn't run any like entire operating system here. Only we need to choose, or we need to provide the dependency libraries and framework for running the application. Coming to container. So here resource, we can utilize our resource maximum. Utilization of resource in the sense of the CPU, memory, everything. Okay. Maximum. Now you will get some understanding of the traditional and the Docker environment. Anyone have any doubt?
And here the Docker engine decides which OS to use for each container, or
No.
we
We need to choose.
we need to use. So there we were using separate OS and having the application in that.
Yes.
But here different application will use the OS. Same
Right, right,
OS.
right.
Okay.
Same OS, that is the base machine OS. Okay. For running this application, we need to install a minimal OS. Minimal OS. Minimal
Okay.
OS within the container. Minimal
Okay.
OS means normal OS size is 1 GB, consider 1 GB. Then the minimal OS size is only 100 MB that we
Okay.
that we use within the container. Okay.
Okay.
Any other doubt? All of you.
So what is the function of the Docker engine here then?
Docker engine manage creating the containers actually. So this is
Okay.
the application that we need to install on top of the operating system. So
Okay.
coming to the Docker lab, I will show you how to configure virtual machine. Then we need to install software, and on the top of the software operating system, we need to install Docker engine, and we need to create Docker containers and
Okay.
deploy application.
Okay.
So here you can see we installed like we configure the the server, and we choose the operating system, and we install Docker engine. So installation of Docker engine is simple. Like we can use Docker command, not Docker command. We can use within single command. We can install Docker engine. Okay. So after we need to create container, right? We after configuring the Docker engine. So how we will configure? I mean, how we will run containers in Docker using Docker. Already we discussed first. I mean earlier in this class. So I will explain one more. For running containers, okay. So coming to Docker. So this is a requirement, okay. So first we need to install, or we need to choose the operating system. Choose OS and server. Server and OS, okay. That is done. Here you can see we choose one server with some configuration of 16 CPU and 30 GB RAM. And we choose the operating system as well, Ubuntu. Consider this is a Ubuntu. So the first part is done. So next thing is this is a scenario, okay? Docker configuration and application deployment to containers from scratch. So the next thing is machine is ready, operating system is ready. Next thing we need to install Docker or Docker engine. So within a single command, we can install Docker engine. So this third step, we need to run our own application. Here you can see 5 applications running. So this is a simple example, okay? So for that, we need to do something. We need to create what? Create Docker
Container.
file. No. For running a container, we need some prerequisite. Like we need to create the Docker file first. What is Docker file? Docker file is a text file that contain that argument, instruction, everything that we need to provide within the container. Okay, this is basically it's a text file that we keep in our operating system. Okay, here you can see we have a Ubuntu server. So in that server directory, we need to create a Docker file. Coming to Docker file D is capital all time. Okay, so keep on mind D is capital. Okay, so this is a basically it's a text file. Okay, it's a text file having instruction, and arguments. As per the requirement, we need to adding that instruction and argument. Okay. Then we have a Docker file with that argument. Everything is we include in the Docker file. So the next stage is this. Now we have only the Docker file. Okay. So we need to build the Docker file. Building means what are the things that we provided in the Docker file, that the argument, everything it's going to build. Okay. So after build, we will get image that we called Docker image. This is after the build. Okay. We need to build. Okay. There's a command for building that Docker commands. After build using the Docker file, we have one Docker file in this case. Okay. So after the building, we will get Docker image. So image means that image have everything to run an application. Okay. I mean the application dependencies, framework, code, everything within the image, because everything we mentioned before in the Docker file. So that will wrap up in and build with a that will build and we will get a image. So the fifth thing is we need to use the Docker image that we get. Okay. So we can use the image to run our application using the image that we have. So after running, we will get containers like this. So the container will start and we can see our application is running inside the container. So these are the like a life cycle or the step-by-step process that we need to go follow using Docker container for deploying applications. Got it?
Yes.
So anyone have any doubt or?
So then where are we gonna use the Docker Compose?
Docker Compose is another service. Okay, we need to install. So I will explain. So
Here all the containers will run like one by one or simultaneously?
one by one.
Okay, so with the help of Docker Compose, we can run all the containers simultaneously.
Yes, I will explain. Okay, this is
Okay, sir. Okay.
this is a scenario of our deploying an application. So deploying an application, we can choose different service. Okay, here we use Docker. First we install Docker, then what we'll do, we need to create a Docker file and we include all the instructions and agreement within Docker file. After that, we will run the image using Docker command. Using the existing Docker file. And after the build, we will get an image. Docker file, image. So we can run the image. Okay. So it will create a container. Okay. So coming to this scenario, okay, when we choose this scenario means we need to run. We need to run. This is a scenario, okay. Scenario where we use Docker. I mean Docker file. Running a container. Okay. In this case, you can see this may be a web application or anything like that. Okay. So running a container, we can choose this method. So coming to another scenario, we need to run multiple container at a single time for single deployment. So coming to this scenario, we need to choose Docker Compose. It's another service actually within the Docker. So we need to install Docker Compose. After installation of Docker, we need to install Docker Compose. Then we need to create a YAML file, a YAML configuration file like app.yaml, app.yaml. And coming to the YAML file, we need to specify everything. Okay, like it's similar, looks like a YAML file, and it's JSON format actually for the YAML file. So we need to specify the which what are the containers that we need to configure, then what are the dependencies, everything that we mentioned in the YAML file. And after that, we need to run the YAML file. So the result is we will get, for example, this is a multi-container deployment. Okay, so in the YAML file, we specify the front-end application, front-end service. So that will be first container. So one more backend there. Backend, some databases are there. We need to provide the database configuration, username, password, everything we mentioned in the YAML file. So for this case, it's multi-container and 4 containers we need to run. So that's the requirement for running the application. So after the run, when Docker Compose run, we will get 4 containers. That 4 containers will be running, and for application of the 4 services runs. So we can see when coming to the Docker, like we can see the 4 containers are running there in this environment, in this setup. Coming to this setup, Docker file setup, we can see only 1 containers running. Got it. So choosing correspondingly. For example, there is only 1 service there, then we can go with the Docker. So multi-container environment, we need to choose this way, like creating everything and choose the YAML file. Only YAML file will allowed here, okay, for the Docker Compose scenario. So coming to the lab, I will show you how to deploy multi-container and how to deploy single container using Docker. Got it. So the Docker Compose, nowadays we didn't use, most of the things we didn't use in Docker Compose because that's why we go to Kubernetes. Okay. So this is a common thing, like the first one, Docker file, Docker build and everything. After here you can see the 4th stage, we got a image, Docker image. So we need to save the image. So where we need to save? Docker hub, the registry. So we can use the same image whenever we need. For example, some other mission. This is one mission, okay? So we log into one of other mission, and we for that mission we need to run the same application. So what will we do? We didn't create any Docker file or anything there because we already have the Docker image. So we can directly pull the image from the Docker hub, and we can run from 4th stage. We can start. No need of Docker this stage. That creation of Docker file and building the Docker image. We can skip that 2 part. We can directly pulling the image from the Docker hub and run the application on this another PC. Okay, this is PC2 like that, or cloud, anywhere we can pull the image, or we can use in Kubernetes as well. Got it. Anyone have any doubt?
No doubt.
All of you?
So far, sir, no doubt.
Okay, now in this theory section, you need to solve, okay, everything. If anyone have any doubt, then we need to sort it out on today. because coming day we need to install, we go into the lab sections. Okay.
So I had one question.
Yes.
So when we are deploying when we are deploying a container in a Kubernetes, so we can use the Docker file or the Docker image to deploy the container in the Kubernetes.
Coming to Kubernetes, we didn't use any Docker file. We only use the image that we built and
Okay,
we saved in the Docker Hub. So the Kubernetes will
okay,
pull the image from the Docker Hub and run the application.
sure.
Like for example,
Can you please undo? Can you please undo the previous screen, like just for a minute? Yeah, thank you.
so yes, we have a Docker file. Then we need to build the Docker file. After build, we will get an image. This is called a Docker image. So this is in our local machine, okay? On local machine or cloud machine, anywhere. So we have the image, okay? So we need to save the image. In real world scenario, coming to the organizational perspective, we need to save the image. So we can save the image to Docker Hub or private registry. We can set up the same way private registry within our uh, system, okay? Like the server or anywhere. So two things we can go. Mostly we go with the central repository like Docker Hub. So we can push this image from this local machine to the Docker Hub. So coming to Docker Hub, we have a username there. Username, then /, then we need to mention the image name. The image name is Apple application, and we can mention the version as well, okay, like V1. So username, then the application, the image name. This is a format when coming to Docker Hub. So this part is done. Okay, we delete the mission or we leave the mission. Okay. So after some time, we have one server. Okay, this server is local. Our mission. Okay, like our local laptop or cloud mission or any mission. Okay, this is a mission, and we need to run the application. Okay, this using the image. So what we'll do? We didn't go to create a Docker file and build. We can directly pull the image, pull using Docker commands. Docker pull, then the image name. This is we need to specify the username /, then the image name. So what will happen here? The Docker will go and search the Docker Hub with the username and the application name. So that meets, then the Docker will pull in the image and it's saved in our that specific machine, and ensure that this image will be public. Otherwise, we can't pulling the image. We need to given the username and password for that image. So we need to make that publicly visible. I mean this image. So we can directly pull the image, and here after the pulling we can see the image here, and we can directly run the image using Docker command. Docker run the image name. So the application running in this specific machine. So anyone can accessing the image if the image is public to their own machines or server or anywhere. So coming to Kubernetes, we have Kubernetes YAML file. Okay. So coming to the Kubernetes YAML file, there is an option for image. We need to mention the image name. So coming to the image name, we need to provide the same thing like the username and the application version. So that is, we mentioned the username / application name. So sorry, the image name. So after running the Kubernetes YAML file, when coming to image, that will looking for the Docker Hub for the image with the corresponding username. So it will pulling the data, pulling the image and running the application. Got it. All of you.
Yes,
Yes.
sir.
Yeah.
Anyone have any doubt? If
No,
not,
sir.
then
Not yet, sir.
okay. Then we can wind up, right? And tomorrow we can start the Docker lab.
Sure.
Okay.
Sure.
Is that fine?
Okay. Have a good night, everybody. Good morning, Tawfiq sir.
Yeah.
Thank you for the class.
And bye all.
Bye, guys. Yeah.
Thank you, sir.
Thank you, sir.
Bye bye. Bye bye.